Welcome to this SUSECON Digital 2020 session, Optimizing Ceph Deployments for High Performance. I'm David Byte, Senior Technology Strategist here at SUSE.
My name is Jason Sparks. I'm a Senior Systems Architect with SUSE. During this session, we're going to look at Ceph and define performance and performance characteristics, processes and tools to help you define your performance of your system, look at OS characteristics and optimizations, try to optimize the Ceph cluster with all of its configuration files and bells and whistles and knobs, and we're going to look at client performance and how you can optimize clients.
So the first thing we really need to do is define what performance really is. And in storage, that has several pieces to it, whether we're looking at individual stream or aggregate performance, whether we're looking at the quickness of a response, latency, which is often measured in IOPS, and then throughput, megabytes, gigabytes a second. What does that really mean?
So the first thing that we need to look at when we're talking about performance is what is an IOP? An IOP is a baseline performance measurement that we use for storage that determines how your storage is going to perform. There's a lot of things to consider as it pertains to IOPS, such as the block size, the write size, the request size, the cache page size, and then finally, what is the block size on the physical disk itself? It does determine read-write, transaction, or bandwidth.
So the next thing when we think about throughput is, are we really talking about single stream or aggregate? So if you tell me I need 10 gigabytes a second, what does that really mean? Does it mean I'm really one single process that needs 10 gigabytes a second? Or is it 100 users each needing 100 megabytes a second? There's a vast difference between that. And Ceph is really not designed for the single stream of 10 gigabytes a second, though with proper tuning and configuration you could get there. It's more designed for the 100 users at 100 megabytes a second, or the 1,000 users at 100 megabytes a second, or more. So next, let's step into the processes and tools a little bit that we use when we're talking about optimizing performance in a cluster.
So it's very important to understand processes and characteristics when you're trying to do performance analysis of a storage array. The first thing that you need to do is define your goal. Is your goal to max out the system or to make it usable for your application? You also need to understand what to measure and how. Do you measure IOPS? Is bandwidth more important? Is transactions more important? Or is latency more important? You need to take these from an incremental point of view or in nature, from the perspective of only change one thing at a time. Measure, repeat, and document. It is very important so that you understand what you've done, how you've done it, so that you can repeat it over and over again and get consistent results.
So when we get down to the point where we're trying to look at these things, there's a bunch of tools. And a lot of these are tools that are built in the system. They're secondary tools that are installable as packages or things that you can find on the internet itself. So some of the most common things like FIO, which is great for generating IO patterns, so you can test. It's actually got some really interesting switches to it where you can say, I want 99% of all IOs within a 5-second window to be under a certain latency measure. That's very useful when you're thinking about what Jason talked about in terms of latency, trying to make sure it's very performant in how fast it responds. And then tools like IOStat, which are more about measuring and seeing what's actually happening, request size, throughput, how busy are the devices. And there's a ton of others there, and we've listed a few here. But it's important to become familiar with these tools before you launch into this work. Make sure that you understand what they're doing. A good, for instance, is for Ceph is when using FIO to do a read test, you actually have to make sure what you're reading from is completely filled first when you're doing block. And the reason for that is because Ceph understands how to deal with sparse and thin provision files. So if you have a file that's full of zeros, it's going to say, hey, the client is, hey, this is just a big file. Here's the range and send back the data. So it looks like you may have a 10 gigabit connection doing 100 gigabytes a second of throughput. Not really possible, but that's what the tools are going to show. And that's why it's so important to understand what's really happening with the tool and you understand how to use them properly.
You know, one of the other things that people need to pay attention to is whether or not you're testing the right hardware. And what we mean by that is, you know, getting demo equipment is great and building a small lab to test performance is fine. But picking the right CPU options, network, the bus, the node count actually will give you that real world performance that you're trying to attain for your application. So if you start small, you're going to get small. If you start too large, you're going to get way too large. So picking the right options for your hardware is key.
So let's talk about getting into the meat of tuning a little bit here. So start with the server hardware. And I'm a hardware freak, and Jason's a bit of one too. So these are things that we really dig into and enjoy a little bit. The first thing we want to look at really is the CPU. You know, all of today's modern processors have power save modes. And that's great. It's fantastic to have power efficiency. But when you're trying to, number one, benchmark, or number two, hit high performance, you really may find these to be detrimental. Probably not so much when you're dealing with spinning media, but certainly when you're talking about all flash or NVMe type media. The action of spinning down to a lower frequency and then back up actually induces latency. So quite often we recommend disabling C states, especially when you're trying to get a standard measure when you're doing benchmarking activities. Again, there are the side channel attacks that we're all painfully aware of at this point in time. There may be situations where you need to or are able to disable those. Clearly you want to visit with your security people, make sure they're okay with it, but disabling some of those can bring back performance in some cases. And then in the firmware, clearly, I'm making a note here about hardware performance bias. A lot of times this is under the power section of the firmware. Make sure you set it to the performance because that really does a lot more about eliminating the C state implications. When you get to things like the disk and network, there are a bunch of other things to check, right? You know, you need to check the status of write cache on or off. There are devices out there that by disabling the write cache, and this is going to seem very counterintuitive, but by disabling the write cache, you actually get an increase in performance out of Ceph. So that's really key to know and to test. You know, this is one of those things you want to test it with it on and then test it with it off. And when you're testing, test it across multiple block sizes like you see in that right column. You know, 4K, 8K, 64K. Move up the stack both with reads, writes, sequential, and random. Make sure that you're matching those up to the workloads that you really need to deal with. And keep in mind, with Ceph, eventually with enough clients, it's an I/O blender, so everything is random. So sequential numbers are maybe not as important as they would be in a traditional array. And then when you get to the network, jumbo frames is the easy one. We always talk about jumbo frames. The other thing, though, is to look deeper down in the network stack. There are a lot of tunables around it. And if you miss some of these, you're going to end up with things like dropped packets. You know, you're going to have soft IRQ misses. There's a lot of indicators to look for here. And really, you need to dig into the performance tuning guides for SUSE Enterprise Storage and SUSE Linux Enterprise to get your hands really wrapped around these and understand the implications. So when we talk about digging into the cluster a little bit, we have the core OSD performance. And there's two things that I always do. One, I always use the kernel client, right? The kernel RBD performance client to look at the performance. And that's because today it's the most performant of the available client options. And the other thing you want to make sure you do is make sure you benchmark each device. So the Ceph-Tel OSD bench, that's exactly what it does. Once you start a bigger test against the entire cluster, use IOStat. Look at your back-end nodes. See if one of the devices is becoming a bottleneck. And if so, you need to dig down and investigate that. It could be something as simple as too few PGs, placement groups. Or maybe you've just got a slow device that needs to be replaced. Quite possible. Um, also, you have to dig into Ceph counters. And this is where it gets a little deeper. There's a performance tuning guide, like I mentioned, for SUSE Enterprise Storage that walks through some of these and points out some important ones. But looking at the Ceph daemon dump can provide some key indicators for you about what's going on and where you may need to tune. And then again, do single stream checks. How is it performing on a single stream? And then check the aggregate to see how well it's scaling. Go from one stream to 10 to 100 to 1,000 or whatever the numbers need to look like, and see how well it's scaling up. So, tuning the OS. There's a lot to gain. In lab testing, this is work that I spent the last year doing. OS tuning doubled or bettered the performance in some situations. Lots of places to tweak the OS. If you look at the kernel level things, you're talking about I/O schedulers, difference between maybe CFQ and NoOp, or enabling multi-queue block I/O, like I mentioned later. There are things like getting rid of TCP congestion management that can improve performance. Making sure you're on the best drivers for your network card and your drive controllers. Those all actually can play quite a role. Now, one of the things to think about is, how do you change these and how do you measure them separately? And that's really what this is to show. This is an eye chart, I'll admit that. But the point is this is a script that I use in my testing to iterate through a bunch of the different things that we needed to measure. If you look here, you'll see things dealing with the ring buffers. That's ETH-G lines. For the NICs, this allows me to push it up and down. There are things where I'm testing, settings for the TCP stack, like the low latency and the fast open. As pointed out earlier by Jason, you need to iterate these one at a time, and having a script that you can use to change these, make your run, reboot everything, run the script with one modification to it, that's really a key thing to being able to get that iterative approach. And something else that I used, since SUSE Enterprise Storage uses SALT for deployment, you can do some really interesting things like using SALT states to apply kernel flags. In this case, you can see we've turned off all mitigations, enabled the block multi-queue functionality. This SALT state enables me to change it across the entire cluster like that, as opposed to having to go to each node. So really a key thing that's very helpful. Again, it's part about understanding the tools available to you and being efficient in the work you're doing. So back to you, Jason.
So now we're going to take you through a couple of steps of tuning the cluster and some things you should try. One of the easiest things you could do is, if you have enough RAM in your servers and you didn't take the bare minimums, is you can allocate more OSD RAM. One of the greatest things about Ceph is the fact that you have a lot of bells and whistles and knobs, and each one of those can increase performance or decrease performance depending on what you're trying to accomplish. But one of the easiest things you could do is allocate more RAM to an OSD device to increase its performance, and basically create a caching between the CPU and the network to the actual spinning disk itself. Another thing we like to talk about is disabling logging. There are 21 different levels of logging, 0 being off all the way to number 20, allowing you to capture most anything and everything that bypasses the kernel or goes through the kernel to present a message to the end user. Next thing is, it's very important. So Rados gateways are for S3 communication to the cluster. Tuning Rados gateway to get you the right block size, the right sharding size, would be very important to guaranteeing your performance either at a single stream or at an aggregate. Increasing MDS cache. If you're using file services and you have an MDS server, a metadata server, increasing its cache to get you that information to and from the metadata server, all that metadata information about what files are used and what it's for and the information contained with it. Increasing that, putting in SSD in the MDS server or NVMe in the MDS server can increase that performance and increase your overall capabilities of getting information to and from the cluster. In some situations, especially with RDB, disabling Ceph X, which is the authentication mechanism, so it's not constantly sending messages across the message bus. If you're in a secure environment and that's acceptable for you to do, we've seen great increases in performance. Last thing I'll talk about is erasure coding algorithms. Erasure coding is a fantastic technology for reducing the amount of capacity and the overhead, or excuse me, increasing the capacity and decreasing the overhead for stored information, but making sure that you have the right CPU, the right algorithm. So Ceph supports many different erasure coding algorithms. Play with each one of them. Find out which ones work best for your data sets. So in our Ceph.conf, we decided to bring forth a few little pieces of information for you to look at. As I mentioned, there are a lot of knobs that you can test with. So this is just one from the general section of the Ceph.conf, where we're turning off all of our debug messaging and we're turning it down to 0, basically making sure that we're not using that CPU overhead for tracking messages during testing. As I said, there are a lot of sections, a lot of knobs that you can turn. This is one where we change our Ceph.conf for our OSD section. And here you can see we're updating our memory target. We're increasing the minimum cache. We're also, one very important thing that I like to point out is the Blue Store minimum allocation size. This could be very important in your environment. If you're writing small block to your Ceph cluster, the default is 64K. Changing the minimum allocation size can A, increase performance, and B, right-size your disk so you're not wasting capacity. Next section here is MDS. You can have multiple active MDS servers, increasing performance that way, or by pinning and creating more cache inside of your Ceph.conf. Increasing that memory size, making sure that more memory is available from the MDS database so clients can get it faster. Finally, Rados Gateway. So in this particular setup here, and this should be available in the download, or just pause the video here so that you can get some idea of what we do for like our IO 500 tests. But here you can see we make a lot of changes to Rados Gateway, a lot of configuration to do such thing as chunk sizing and sharding and object stripe size. All of these things can affect performance and provide you with a much better, cleaner running system. Caching. So one of the greatest things about Ceph is the fact that you can create different tiers of storage. One of the things that you could do to increase your storage performance right away is to include SSD or NVMe in your replacement groups in your structures. So ensure that working files are within the right tier. So again, by doing NVMe, you can increase your transactional performance most immediately, or that bandwidth that you're looking for most immediately as well. Good workloads like media and editing and databases run very, very well with NVMe as a primary tier or that caching tier. For more information, check out the Enterprise Storage Administration Guide, section 14. David?
So the next thing to really dig into a little bit is tuning the client. And there's quite a few things that we could look at there. And I think we'll let Jason jump in on talking about the client stuff to start with.
Sorry, I thought you were doing this one. Client stuff. So bad hardware choices can't be fixed by software. We can't stress this enough. Software can only do what the hardware allows it to do. So some of the things that people need to take into account are, where are the performance thieves? Antivirus is one of the biggest ones, especially if you don't have the ability to exclude certain directories for temp files, for caching files. Every time you write to one of those, antivirus says, hey, are you a bad file or are you a good file? Think about all the wasted resources for that. So in a secure environment, we recommend creating write locations where antivirus is excluded so that therefore those CPU resources are there to store files. Resource completion and routed connections. When you're on a routed connection, it's very, very important that those routes are clean and stable and that they have the shortest path. And power saving technology, as David touched on earlier in this presentation, make sure that your power saving technology is turned off so that you can get the maximum amount from your CPU, network, and bus.
So let me give you a real world example on, antivirus actually being a performance thief. One of the things that I saw when I was working on a reference guide for a backup application was that the media server had on-access scanning in place, but it wasn't for the target, right? So you wouldn't think that it's actually going to be a problem. Turns out it was, because what it was doing is as the files were coming in and due to the way the application was receiving those across the network, they were getting scanned as they came in on the network, not on the storage side, right? Not on write. So by disabling the antivirus, we actually double the performance in that environment. And then, in case you didn't know, all modern servers that aren't Linux pretty much include some form of virus scanning, whether it's a separate application or one that's embedded in the OS. So you need to watch out for those and make sure that it's not hitting you, because it'll sneak up on you. So real quick, talk about Rados block device. There's some tuning you can do in it. Client-side caching, write caching. Now you can set it in write back or write through mode, but you have to think about what that means. If you're putting it in write back mode, you're actually putting some data at risk on the client side. If that risk is acceptable, meaning if the client disappears and takes some data with it, it's no big deal, great, enable it. If not, you probably don't want to do it. If it's a client that's doing writes and then needs to read back that data fairly soon, a write-through cache is very helpful. There's also things like client-side read-ahead caching. That's an option to tune. Again, look at the storage admin guide and the performance tuning guides. Those have a lot of information in them. And one other thing that's out there, and it's not a huge impact today because there's some patches still coming in an upstream kernel, but by the time we get to SUSE Enterprise Storage 7, I think you'll see these, and that's the enablement of multi-queue block I/O for Rados block devices. So that'll actually be a really great enhancement that we should see come down the line. For Ceph, the distributed file, there are some settings that we use on the client side to improve performance. You have to understand these. They look very similar to NFS mount options, so they should be relatively similar. No ACL. Don't update the ACLs. That actually saves a lot of metadata time. No A time, no dir A time. Those are important as well. And then there's another one called no CRC. Now this one's a little more questionable because what you're doing is you're disabling a CRC check to make sure that the data that was sent is the data that was received. You can try and rely on the networks, and in most cases you're probably okay. But what you don't want is silent data corruption. So please really think hard about how important the data is before you go in and disable that one. But it is there for you to work with if need be. So in wrapping up, we've got a few points to share. As Jason said, there's lots of knobs. He talked about being methodical in your approach. That's really key. Make sure you record the results. Record each iteration. That way you can go back and compare. And then share the knowledge. That's the biggest thing for me, is making sure as an open source company that we share what we have in our documents. You go to our website. They're not behind a paywall or anything like that. You have access to them. So make sure you're sharing what you come up with, because it helps the entire community. Any final thoughts, Jason?
Thank you all for watching this video today. We hope you learned something. Both David and I are available to you at any time. Feel free to reach out to us through your SUSE contact. We're happy to help.
Thank you, guys.